physics lesson with Mr. M. In today's physics lesson, I'm going to teach you how we can solve for resistance, current, and voltage in a parallel circuit. So first of all, we want to take a look at our circuit diagram here. We know that this is a parallel circuit due to the fact that parallel circuits have multiple paths for electricity to flow, and the rules that we're going to be using for solving parallel circuits is based on this idea, this concept that there are multiple paths for electricity to follow. Okay, and just to visualize that, what's happening here is that as the current is flowing, or as that electric charge is moving through the circuit, that current basically has a choice. Not that it's actually choosing, but a choice for it to either flow down this branch or to keep going along and maybe flow down this branch, or keep flowing and then finally move down this last branch. Okay, but this is how we can know that we're working with a parallel circuit. Okay, our first rule that we're going to talk about is the rule for resistance. And in a parallel circuit, the total resistance varies inversely with the current. Okay, and this idea is that the more branches we have, the more we divide up the electric current. Okay, and because of that, we say that the resistance is inverse to the current, and to represent this mathematically, our inverse is basically our reciprocal. Okay, so our total resistance is inversely related, and the way that we complete this rule is that we add up all of our resistors. So it looks something like this. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you have more, you're going to continue that. Okay. Our next rule has to do with current. Okay, and because current, this electric charge is, in essence, choosing which branch to flow down. Some of that current is kind of being lost at each branch. Okay, but once it flows through all of the branches, it adds up to what it used to be. So we say that our total current in a parallel circuit, we just add up all of the currents that flow through each of those branches. So I1 plus I2 plus I3 gives us our total current. Okay. And lastly, our rule for voltage. Voltage in a parallel circuit is going to be the same throughout. Okay, so our total voltage, our total change in voltage is the same throughout. So we represent that mathematically with our equal signs. So V1 is equal to V2 is equal to V3. Okay, so whatever our total voltage is, which comes from the battery itself, or whatever our power source is the same throughout. Now we're going to use these three rules in conjunction with Ohm's law, which you should be familiar with. V equals IR. Okay? So now let's go ahead and take a look at our circuit diagram so that we can actually solve for the problem at hand. I always teach my students to start with the given information. So we know that we have a power source of 60 volts. So that's going to be our total voltage. So our total voltage is 60 volts. And we know our three resistors. So R1 is 17 ohms, R2 is 12 ohms, and R3 is 11 ohms. All right. So at this point, we need to utilize our rules to solve for our remaining values. Okay. And by the way, I always like to set up my circuit problems like this. Okay, where I've got my total values, resistance, current, and voltage at top, and then I break down each of the individual parts from there on out. So let's start with our voltage here, because that's one of our easier rules. The voltage is the same throughout. So if my total voltage is 60, I know that the rest of my voltages are also going to be 60 volts. So we can fill that in. Okay. And next, I want to attack this total resistance. And the reason why is because I know all three of my resistors. Okay, so let me show you how we do that. We're going to utilize our first rule here, where our resistance is an inverse, okay, or the reciprocals. So 1 over total resistance is going to equal 1 over R1, which is 17. We're going to add that to 1 over R2, which is 12. And we're going to add that to 1 over 11, which was our third resistor. Now, when we add up these three reciprocals, we end up with a decimal of 0.233. Now, here's where a lot of students make their mistake. They think, oh, hey, I added all of these up. This right here is my total resistance. Okay. However, it is not your total resistance. Okay, because our total resistance is in the denominator of this fraction. Okay, it's a reciprocal. So we need to understand that this 0.233, we have to do something with it first before we get our total resistance. Okay, as mentioned, the total resistance is inverse. So what we have to do is we have to get this R value on our numerator. So we have to flip it, okay, or we have to reciprocate it. So we're going to flip this fraction so that my total resistance is now in the numerator. Well, whatever we do to one side of an equation, we have to do to the other side. Keep in mind, this 0.233 is a fraction in itself, just divided by 1. So just like we flip these, we have to flip these as well. So my 1 is now going to go on top, my 0.233 is going to go on the bottom. So this looks something like this. Total resistance is equal to 1 divided by 0.233. Okay. When you go ahead and plug this in, then we actually get our total resistance, which comes out to be 4.29 ohms. Alright, so that's an easy mistake that you can make if you forget to reciprocate your fractions there. So total resistance ends up being 4.29. Now that I know my total resistance, I can then find my total current because I have my total voltage. Alright. Keep in mind when you're solving, as we see here, we have to solve for I1, I2, and I3. We have to kind of keep like terms. So if I'm solving for total current, I need to use total resistance, total voltage. If I'm solving for I1, I have to use R1 and V1. Okay, so keep that in mind. Since all we have is current left, I'm going to rearrange Ohm's law just to solve for current. So I'll show you how we can do that. To get I by itself, we divide by R. So my R's go away. So my current is equal to the voltage divided by the resistance. So let's go ahead and use that version. So my total current is going to equal the total voltage divided by the total resistance, which we had solved for. So my total current comes out to be 13.9 amps. We can fill that guy in. Now we got to solve for I1, which is going to be 60 volts divided by R1, which is 17 ohms. 60 divided by 17 gives us 3.5 amps. Now my I2, same method, 60 volts divided by 12 ohms, we get 5 amps. And then lastly, I3 is going to be 60 volts divided by 11 ohms. We end up with 5.4 amps. Okay, so we can plug those values in. 3.5, 5.0, and then 5.4 amps. After solving these three currents, we can self-check utilizing our second rule, where if we add up all of our currents, we should get the total current. If we were to do 3.5 plus 5 plus 5.4, it would all total up to 13.9. So in review, our rules for parallel, our total resistance is, you're going to be using the reciprocals, okay, for each of those resistors. For total current, you just add up all of the currents from each of the branches, and then our total voltage is going to be the same throughout the entire circuit. Okay, so hopefully watching this video helped you solve your own parallel circuit problem. Thanks for tuning in.